Okay, so in this section, we will extend the definition of the definite integral to include the case of an infinite interval of integration. And in the next section, we will consider the case when the integration may become discontinuous or infinite at some points in the interval of integration. So in both cases, the extended integral is called an improper integrals. Okay, so ibig sabihin nun, dito sa improper integrals, unlike doon kasi sa definite integral na na-discuss na natin sa chapter 2 na fixed yung interval. Ibig sabihin, fixed na, alam natin kung ano yung interval na given. Ibig sabihin nun, constant siya or real number. So, dito sa improper integrals is, i-extend natin dito yung definite integral na ang interval niya is an infinite integral. Ibig sabihin nun na pwedeng maging positive infinity or negative infinity yung magiging interval niya. Okay, doon din sa next after this section is yung magiging integral natin is magiging discontinuous siya or infinite at some point in the interval of integration. So, dito muna tayo sa section na to, improper integrals with infinite limits of integration. So, we have the integral of f of x dx from a to b. So, di ba ang tawag natin dito is definite integral kasi may limit man siya. Have been defined when, okay, so here in improper integrals, the interval or closed interval AB is of finite length, di ba? Kasi closed interval, ibig sabihin fixed. Alam natin na real number yan or constant siya. And then, f of x is bounded on the closed interval AB. So, extend the proofs of integration by type. So, we have two types. Allowing the length of integral of integration to be infinite, unbounded integrals. Okay, so infinite ibig sabihin unbounded integrals. Pwedeng approaches to the positive infinity or approaches to the negative infinity. Okay, the next one is allowing the function f to be unbounded. These integrals are termed as improper integrals. So, ang tawag sa mga integrals na ang interval niya is unbounded integrals is an improper integrals. Okay, so we have a definition here. So suppose that f is continuous for all x greater than or equal to x sub o if the limit of the function or if the limit of the integrand f of x dx from x sub o to a as a approaches to positive infinity exists. So we can say that the integral of the function f of x dx from x sub o to positive infinity is convergent to that value given by the above limit. So, ibig sabihin nun, pag kinuha natin yung limit na to, etong si f of x, from x sub o to a, where a is approaches to positive infinity, pag nag-exist yung limit niya, we can say that this integrand is convergent. Okay. Okay, kung convergent, may makukuha tayo na define na limit. If the limit does not exist naman, we can say that the integral of f of x dx evaluated from x sub o to positive infinity is divergent. And the integral is not defined. Ibig sabihin nun, yung limit na makukuha natin is undefined or it's either positive or negative infinity. So, ang tawag doon sa integral na yan is divergent. Kung may mag-exist na limit, ang tawag is convergent. Okay, so for example, evaluate the integral of 1 over 1 plus x squared dx evaluated from 0 to positive infinity. So kung makikita ninyo dito sa improper integrals, may positive infinity or negative infinity na sa interval niya. Unlike kasi doon sa definite integral na alam natin na number talaga siya. Alam natin na fix yung number na given sa interval. Okay, so here, so since the integral of 1, okay, so di ba ang integral ni 1 plus 1x squared, 1 over 1 plus x squared dx is equal to the arctangent x plus c. Okay, di ba kapag plus, and then, eto siya is a perfect square and also x, ang exponent niya is 2. So, ang integral nito is the arctangent x over a. So, u over a rather. So, since ang u natin dito is the variable x and then ang a natin is 1. So, x divided by 1 is just equal to x. So, eto yung integral ni 1 over 1 plus x squared. So, ibig sabihin si arctangent x, yan yung i-evaluate natin from 0 to a. Okay, si positive infinity dito class, yan yung a natin doon sa definition ni convergent. Okay, so we have the integral of 1 over 1 plus x squared evaluated from 0 to a. Si positive infinity, pinalitan lang siya ng variable a. Okay, diba ang integral nito is galing siya dito, that is the arctangent x. Okay, evaluated from 0 to a. So, i-evaluate natin siya. So, arctangent of a minus the arctangent of 0. So, arctangent of 0 is equal to 0 na siya. So, we left with the arctangent a. So, after ninyong ma-integrate, okay, so ang first step dito sa improper integral is i-integrate nyo muna yung given na integrand, hindi nyo muna iisipin yung interval na given. And then after ninyong makuha yung integral niya, saka nyo na siya i-evaluate, and then yung positive infinity kung nandito siya sa taas, always nandyan is positive infinity. Kung dito kasi negative infinity yung nakalagay dito. Okay, so i-replace nyo lang yung si positive infinity ng variable a. And then after, pag naka-evaluate na kayo ng integral, na-evaluate nyo na yung integral, kukunin nyo na yung limit niya. Thus, the limit of the arctangent of a as x approaches positive infinity. So, ibig sabihin si a dito is papalitan natin yan ng positive infinity. So, arctangent of positive infinity is equal to pi over 2. Okay, so pi over 2 yung equivalent ni arctangent a. So, therefore, it is convergent. So, convergent siya since may nag-exist man na limit na pi over 2. And pi over 2 is defined that is equal to 90 degrees. And the integral of 0 to positive infinity 1 over 1 plus x squared dx is equal to pi over 2. So, ibig sabihin, ang integral nito is kung ano yung nakuha natin na limit niya. So, that is for the first example. Another example is the integral of 1 plus 1 over x squared dx evaluated from 1 up to positive infinity. So, ang first step, i-integrate muna natin yung integrand. Okay, so, integral of 1 over x squared dx is, eto siya, equivalent siya as x to the power of negative 2 dx. So, integrate natin si x to the power of negative 2. Ang integral niya is x to the power of negative 1 over 1 plus c. Or, we can rewrite this one, or the equivalent of this is negative 1 over x plus c. So, eto yung nakuha natin na integration niya. And then, after that, pwede na natin siyang ma-evaluate. And then, si positive infinity dito is i-replace natin siya ng variable a. So, eto, naging integral. Okay, so isulat ko na lang dito. Eto siya, magiging integral of 1 over x squared from 1 to a. Si positive infinity, pinalitan lang siya ng variable a. Okay, so ang integral nito class, galing dito is negative 1 over x, okay, from 1 to a. So, i-evaluate natin. So, negative 1 over a, replace x by a, minus the negative of 1 over 1, okay. So, this one is negative 1 over a, positive times the negative 1 over 1 is positive 1. Okay, so ibig sabihin, eto yung kukunan natin ng limit. Okay, so the limit of negative 1 over a plus 1 as a approaches positive infinity is equal to 1. Kasi diba negative 1 over positive infinity, kahit ano yung ilagay natin dito na number, saka the more na palaki ng palaki yung number niya, the more din na lumiliit yung value niya. So, ibig sabihin nun, mas malaki pa rin yung value ni 1. So, that's why the limit of this is equal to 1. Okay, so since may nag-exist na limit, we can say that this integrand is a convergent and it is equal to 1. Yung 1 na yan, galing siya doon sa pag-evaluate natin ng limit. Okay, so that is for the second example. Another example is negative infinity siya. So, ibig sabihin dito sa baba ng interval natin. Sa baba nakasulat sa integral sign natin. Kasi kanina kasi yung previous two examples is lahat positive infinity. Okay, so here, integral of dx over the square root of 1 minus x evaluated from negative infinity to 0. So, i-replace pa rin natin dito class kay negative infinity is equal to a. So, eto, pwede natin siyang masulat as a to 0. Okay, take note, always dito isusulat si negative infinity. Kung positive infinity naman is dito sa taas. Okay, so simply replace negative infinity by a. So just copy 0. So we have dx over the square root of 1 minus a. So before that, i-integrate muna natin si dx over the square root of 1 minus x. Okay, so we can let u is equal to 1 minus x and then du is equal to negative dx. Okay. And okay, so substitute natin dito. So, replace dx by negative du and then square root of 1 minus x is u. So, that is equal to the square root of u. So, ang integral nito is du over u to the power of 1 half. So, iakyat natin sa taas. That's why naging negative. Si negative, finactor out dito ha. So, ang integral nito u to the power of negative 1 half plus 1 is 1 half over the 1 half. So, ibalik natin siya in terms of variable x. We have negative 2 square root of 1 minus x plus c. So, sa pag-integrate ninyo, na hindi pa nasali yung limit niya or interval niya or the limit is eto yung i-evaluate ninyo. Okay. So, eto, equivalent siya as negative 2 times the square root of 1 minus x. Okay, evaluated from 0 to a. So, replace x by 0. So, we have negative 2 square root of 1 minus 0. Then here is negative. Minus times the negative of 2 times the square root of 1 minus a. So, eto, negative 2 kasi 1 minus 0 is 1. Square root of 1 is 1 times 2. Times the negative 2 is negative 2 pa rin. So, we have minus. So, negative times the square root of 1 minus a. So, hindi yan pwedeng i-add ha. So, 1 minus a pa rin yan. So, negative times negative, that is positive 2 square root of 1 minus a. So, eto yung kukunan natin ng limit. Okay, so the limit of negative 2 plus 2 square root of 1 minus a as a approaches negative infinity. Kasi yung given natin dito is negative infinity. Kanina kasi sa dalawang examples, previous examples, a approaches to positive infinity. Kasi ang interval ng x natin is from 0 to or from 1 to positive infinity. Okay, so ang limit nito magiging negative 2 plus 2 square root of 1 minus the negative infinity. So, magiging negative 2 plus 2 times the square root of positive infinity. Kasi, di ba 1 minus the negative infinity is infinity. Kasi, di ba mas malaki yung value ni infinity kaysa kay 1. So, that's why ang result nito is infinity. So, 2 times the square root of infinity is infinity pa rin. So, negative 2, i-add mo siya kay positive infinity, that is equal to infinity pa rin. Kasi di ba mas malaki yung value ni infinite kaysa kay negative 2. So, therefore, it is divergent. Kasi yung lumabas dito na limit is not defined. This is an infinite limit. Okay, so that is for the example number 3. Okay, eto naman sa example na to, dito sa example na to, x e to the power of x squared dx. So, determine or evaluate if it is convergent. So, we can say that the given integral is convergent if the limit exists. And we can say that the given integral is divergent if the limit does not exist. Okay, so by the definition, if there exist finite values L sub 1 and L sub 2 such that, okay, the integral of x e to the power of negative x squared dx evaluated from a to 0, okay, as a approaches negative infinity, and then ang limit nito is equal to L sub 1, and then the integral of x e to the power of negative x squared dx from 0 to b, where b is approaches to positive infinity. Kumbaga, eto siya class is, anong ginawa dito? Ni-split lang siya or pinaghiwalay lang siya as the integral of negative infinity to 0, x to the power x e to the power of negative x squared dx plus the integral of 0 kasi 0 yan, di ba? So nag-stop tayo kay 0, mag-start na naman tayo ulit kay 0 and then to positive infinity. So x e to the power of negative x squared dx. Okay, so ibig sabihin, i-integrate natin to, i-integrate din natin yung term na yan. And then, yung limit na makukuha natin sa dalawa na yan is i-combine natin. Okay, then, okay, so we have the integral of negative infinity to positive infinity x e to the power of negative x squared dx is equal to the limit of L sub 1 plus the limit of L sub 2. Okay, so unahin natin si x e to the power of negative x squared dx. So to integrate this one, we let using the substitution. So let u is equal to negative x squared, and then du, ang derivative nito is negative 2x dx. Okay, so divide it both sides by negative 2. Okay, so di ba magiging negative 2 yan? Okay, so divided both sides by negative 2. Okay, so magiging negative du over 2 is equal to x dx. So si x dx, simply replaced it by negative du over 2. So nilabas ko na dito si negative. So we have e to the power of u. Kasi diba ang gilat natin na u is a negative x squared. So pwede nating i-factor out dito si 1 half. So we have negative times 1 half is negative 1 half. Integral of e to the u du is negative 1 half e to the power of negative x squared plus c. So ibig sabihin nun, eto yung kukunan natin ng limit. Okay. Yeah. No, ito yung gagamitin natin sa pag-evaluate. Okay, so kumbaga, ito yung gagamitin natin na integral sa pag-substitute natin dito or sa pag-evaluate natin ng limit. Okay, so here we have the integral of x e to the power of negative x squared dx is equal to 1 half e to the power of negative x squared. So, yung nakuha natin kanina na integral niya. So, eto yung result. So, it is evaluated from a to 0. Okay, so magiging negative 1 half. This is e to the 0 squared. This is e to the 0 minus e to the power of negative a. Kasi si x, replace it by a. So, we have negative a squared. So, negative 1 half times e to the 0 is 1 na yung e to the 0. Equivalent nito ha, e to the 0 is equal to 1. Ito naman, pwede natin siyang ma-express as 1 over e to the power of a squared. Since negative yan, lagay natin sa baba para maging positive. Okay, so kukunan natin to ng limit. So, ang limit nito is the integral of negative 1 half the integral of x e to the power of negative x squared dx is equal to the limit of, eto siya, just bring down this one. Okay, so negative 1 half times 1 minus 1 over a to the power of a squared as a approaches negative infinity. Kasi nandito si a sa baba. Kung nandoon, approaches to positive infinity. So kung eto, i-substitute natin dito si positive infinity. So, infinity pa rin yan. So, 1 over infinity is the more na palaki ng palaki yung number, mas magiging malaki pa rin yung value ni 1. So, that's why etong nasa loob ng parenthesis na yan, that is equal to 1 na lang. Okay? Times negative 1 half, that is equal to negative 1 half. Okay, so similarly, etong pangalawang integral niya, kasi diba hinati yan, ito yung first. So, ang nakuha natin na limit niya is negative 1 half. So, ito naman, titingnan natin kung ano yung makukuha natin na limit nito. So, the same process pa rin sa pagkuha natin sa limit nito. Okay, so since na-integrate na natin to, so ang integral niyan is negative 1 half e to the power of negative x squared. So, ang pinagkaibahan, ang i-evaluate natin to from 0 to b. Kanina kasi is from a to 0. So, replace natin si x ng b. So, magiging negative 1/2 e to the power of negative b squared minus e to the power of 0. So, this one is 1 na lang yan. Ito is 1 over e to the power of b squared times negative 1/2. So, to get the limit of this, we have the limit of negative 1/2 times 1 over e to the power of b squared minus 1 as b approaches to positive infinity. So, ang sabi ko kanina, the more na palaki ng palaki yung number natin dito, mas liliit yung value na, and then ima-minus natin siya ng 1, 1 pa rin yung sagot. So, negative 1/2 times negative 1 is positive 1/2. Hence, the integral of 0 to positive infinity x e to the power of negative x squared dx is equal to 1/2. Diba? Ito yung first na nakuha natin kanina na yung sa pangalawa pala, 0 to positive infinity or 0 to b. So, kung i-add natin si negative 1/2 and 1/2, ito yung limit ni a to 0, x e to the power of negative x squared, and then ito naman is yan yung limit niya. Okay, so negative 1/2 plus 1/2, that is equal to 0. So, this is the integral of this given integral. Okay, so ito yung sinasabi natin kanina na next section, improper integrals with discontinuous integrands. Kanina kasi improper integrals with infinite limits. So dito, improper integrals with discontinuous integrands. So we have three cases to consider here in this topic. So the first case is f of x is discontinuous at x is equal to a, and the integral of f of x dx from a to b is equal to the limit of a plus epsilon to b f of x dx as epsilon approaches 0 to the positive infinity, or epsilon approaches 0 to the right. Okay, ibig sabihin nun, si a dito is nag-add tayo ng epsilon. So, ibig sabihin si epsilon is approaches to the right. Okay, the next case is f of x is discontinuous at x is equal to b. Kung saan siya discontinuous class, kung dito siya discontinuous sa baba, mag-a-add kayo ng epsilon. And then, kung discontinuous naman siya sa taas, magma-minus kayo dito ng epsilon. So, yun yung sa case 2. So, at discontinuous daw yung function natin na f of x at x is equal to b. And the integral of f of x dx from a to b is equal to the limit of a. Okay, so since dito siya discontinuous kay b, so that's why doon siya nag-minus ng epsilon. So our epsilon is always ito approaches 0 to the right. Okay, so take note, sa case 1 and case 2, kapag discontinuous siya dito sa baba, magma-minus kayo ng epsilon. And then, kung dito naman siya discontinuous sa taas, kung dito siya discontinuous sa baba, mag-a-add kayo ng epsilon. Kung dito siya discontinuous sa taas, magma-minus kayo ng epsilon. And then take note, si epsilon dito class sa improper integrals with discontinuous integrands is always yan approaches 0 to the right. And then the last case, f of x is discontinuous on a, on C, okay, where C is from A to B. Ibig sabihin nun, discontinuous siya sa, is between sa interval ni C. So, halimbawa, discontinuous siya, okay, so for instance, 1, 3, so discontinuous siya kay x is equal to 2. So, ibig sabihin, hahatiin natin tong interval na to. So, we have the integral of f of x dx from a to b. So, since discontinuous siya kay kay c, where c is between a to b. So, eto, pwede natin siyang mahati as the limit of the integral of f of x dx from a to c, where c is yan yung between sa interval ni a and b. And then, dito siya discontinuous. Okay, f of x dx plus the limit of f of x dx as evaluated from. Okay, so since discontinuous kay C, okay, kung nag-stop tayo dito kay C, mag-start tayo dito kay C, mag-end tayo kay B, where C is between kay A and B. Okay, so this is equal to the limit of a to the power of c minus epsilon, kasi di ba discontinuous siya dito. So take note, kung saan siya discontinuous, ibig sabihin magiging 0 siya doon or magiging undefined siya doon sa value na yun is magma-minus tayo ng epsilon if dito sa taas. And then kung dito naman siya discontinuous sa baba, mag-a-add tayo ng epsilon. So eto class, equivalent lang siya dito. Okay, so para mas maintindihan natin yung tatlong cases na yon, so we have an examples here. So for the first example, the integral of dx over x, the square root of x minus 1, evaluated from 1 to 3. So titingnan natin class kung ano yung value ng x na makaka-zero sa denominator natin. So ibig sabihin, doon siya discontinuous. So, dito sa given natin class, ang value ng x na magiging 0 ito is x is equal to 1. Okay, so take note, ang interval natin dito class is from 1 to 0. Okay, so from 1 to 3 rather. So, the integrand f of x is equal to, okay, di ba, ito yung integrand natin, si 1 over the square root of x minus 1. Is discontinuous at x is equal to 1. So, kaya ko sinabi na discontinuous siya at x is equal to 1 because when we are going to substitute x is equal to 1 here, so maging 1 minus 1 is 0. So, square root of 0 is equal to 0. So, 1 over 0 is undefined. So, pag naging undefined siya, ibig sabihin discontinuous siya sa point na yon. Okay, so which is in the left end point of the interval of the integration. So, di ba ito yung interval natin from 1 to 3. So, si 1 kasi nasa left end point siya ng interval of integration natin. Kung dito siya discontinuous kay 3, ibig sabihin nun, nasa right end point siya of the interval of integration. Okay, so integrate muna natin ito before natin siya before natin kukunin yung limit niya. Okay, so ang integral ni dx over the square root of x minus 1 is 2 square root of x minus 1. So, actually, parang parehas lang to doon sa previous example sa type 1 ng improper integrals or doon sa previous section. So, ang integral nito is 2 square root of x minus 1. Okay, so i-evaluate natin siya. Okay, so since dx over the square root of x minus 1 evaluated from 1 to 3, since discontinuous siya dito sa 1, so si 1 kasi nandito man siya sa baba, kasi di ba yung 1 yung makaka-0 dito. So since discontinuous siya dito, mag-a-add tayo ng epsilon. So we have, integral nito is 2 times the square root of x minus 1 evaluated from 3 up to 1 plus epsilon. Okay, nalagyan to ng 1 plus epsilon because discontinuous siya dito kay 1. Kung doon siya discontinuous sa taas, magma-minus kayo ng epsilon. Okay, so 2 square root of x minus 1 evaluated from 3 to 1 plus epsilon. So, magiging 2 square root of 3 minus 1 minus 2 square root of 1 plus e. Si x is replaced it by 1 plus e and then minus 1, minus 1. So, cancel out si 1 minus 1, that is equal to 0. So, we have 2 square root of epsilon. So, ito yung kukunan natin ng limit. So, the limit of the integral of dx over the square root of x minus 1 is equal to 2 square root of 2. So, since nag-exist yung limit niya, so, we can say that it is a convergent. Okay, so let's continue our discussion sa improper integrals with discontinuous integrands. So, nagbigay na ako ng ibang example, so bibigay ako ng additional example pa. Okay, so for instance, evaluate the integral of dx over 1 minus x evaluated from 0 to 1 if it exists. Okay, so iti-test natin to if this given integrand is exist. Okay, does exist. Okay, so the integrand f of x is equal to 1 over 1 minus x. Diba ang integrand natin dito class is 1 over 1 minus x. Okay, so discontinuous siya at x is equal to 1 kasi diba pag pinalitan natin si x ng 1, ang magiging denominator natin is 0. So which means kapag 0 yung sa denominator, that is undefined. So pag undefined siya, ibig sabihin nun discontinuous siya doon sa interval na yon or sa point na yon. Okay, so which is the right endpoint of the interval of integration. Kasi di ba ang interval natin dito class is from 0 to 1. So ibig sabihin si 1 dito siya discontinuous, which is in the right endpoint, which is the right endpoint of the interval of integration. Okay, so before natin ma-test if it does exist, kailangan muna nating kunin yung integral ni dx over 1 minus x. So, but before that, eto siya, we can rewrite this one as the integral of dx over 1 minus x evaluated from 0 to 1 minus epsilon. So, as I have said sa previous discussion natin, sa previous videos na na-discuss ko is kung saan siya discontinuous, it's either mag-a-add or magsasubtract kayo ng epsilon. Kung sa taas siya discontinuous na interval or sa right endpoint, you have to subtract epsilon, and then if it is discontinuous in the left endpoint of the interval of integration, ibig sabihin dito sa baba is mag-a-add kayo ng epsilon. Okay. So, integrate muna natin to. So, ang integral ni dx over 1 minus x is we let u here as 1 minus x, and then derivative of 1 minus x is the negative dx. So, we have negative du si dx, and then replace 1 minus x or substitute 1 minus x by u. So, the integral of this is the negative of ln of u plus c, or the negative of ln of 1 minus x plus. So, ibig sabihin nun, ito yung integral ni dx over 1 minus x. Okay, so i-replace natin dito. So, we have here the integral of dx over 1 minus x is equal to the negative of ln of 1 minus x. Galing siya dito. So, it is evaluated from 0 to 1 minus epsilon. So, ang result sa pag-evaluate natin is magiging negative ln of the negative epsilon. Kasi diba eto siya class, 1 minus 1 is 0 na yan. So, we left with negative times negative. This will become positive epsilon. This is not negative ha. This is positive epsilon. Okay. So, minus the ln of 1 minus 0. So, the negative ln of 1 minus 0 is the negative ln of 1 times the negative here is outside. So, magiging positive ln of 1. And then, ln of 1 is equal to 0. Okay, so, this one is magiging ln of positive epsilon, negative ln of positive epsilon. Okay, so, since na-evaluate na natin siya, ang next step is kukunin natin yung limit niyan. Okay, so the limit of the negative of ln of, this is positive epsilon ha. Okay, this is positive 0. Okay, the limit of the negative of ln of epsilon as epsilon approaches 0 to the right. Okay, so this is negative ln of, okay, replace epsilon by 0. So, the negative ln of 0 is, okay, so the negative ln of 0 is positive infinity. So, positive infinity times the negative is, this one is negative. Okay, so this is negative infinity. Since the limit does not exist, therefore it is divergent. So since ang nakuha natin na limit is hindi siya defined, kasi infinite yung nakuha natin na limit, we can say that the given integrand is a divergent. Okay, so that is for the next, for the example number 2. So we have another example here. The integral of 1 over x squared dx evaluated from negative 1 to positive 1 if it exists. Okay, so since si integrand natin, okay, so diba ang integrand natin dito class is 1 over x squared is discontinuous at x is equal to 0 because when we substitute 0 here, magiging 1 over 0 and it is undefined. So we can say that this given integrand is continuous in the given point 0. So which is in between in the interval negative 1 and 1. Okay, so since ang interval natin is from negative 1 to 1, since discontinuous siya sa 0 in which si 0 is nasa gitna ni negative 1 and 1. So, ibig sabihin nun, eto siya, mahahati natin as hahatiin natin to, etong interval natin into 2 or split natin siya into 2. So, ang mangyayari is from negative 1 to 0 kasi diba discontinuous siya sa point na 0. So, which means negative 1 to 0, that is, si 0 is in between kay negative 1 and 1. Okay, so negative 1 to 0, 1 over x squared dx plus the integral of 0 to 1 1 over x squared dx. Okay, so integral of 1 over x squared dx, 0 to 1. Okay, so eto class, yung 0 na yan dito at saka 0 dito is kung saan siya discontinuous na point. Okay, so since discontinuous siya dito sa point na to, ibig sabihin nun, magma-minus tayo dito ng epsilon. So, ang mangyayari is, heto, magiging negative, integral of 1 over x squared dx evaluated from negative 1 to 0 minus epsilon. And this one also is, since discontinuous siya dito sa point na to, mag-a-add tayo dito ng epsilon. So, we have integral of 1 over x squared dx evaluated from 0 plus epsilon to 1. Okay, so, before natin kukunin yung limit nito, kasi di ba kukunin natin yung limit nito at kukunin din natin yung limit niyan. So, ang first step is integrate first the given integrand. Okay, so assuming that indefinite integral muna siya. So, we have the integral of 1 over x squared dx is equal to the integral of dx over x squared. So, iakyat natin si x squared sa numerator para mas madali natin siyang ma-integrate. So, magiging integral of x to the power of negative 2 dx. So, adding 1 to the exponent and bring it down to the denominator. So, magiging x to the negative 1 over negative 1 plus c is equal to 1 over the negative x, or equivalent lang din yan class as negative of 1 over x. Okay, so thus, we have here, so eto yung i-evaluate natin. Okay, yan yung i-evaluate natin. So, unahin muna natin yung etong sa first term. So, we have the integral of 1 over x squared dx is equal to negative 1 over x. It is evaluated from negative 1 to 0 minus epsilon. So, eto muna yung focus natin. Okay, so, if we substitute 0 minus epsilon here, we have negative 1 over 0 minus epsilon minus the negative of 1 over the negative 1. So, magiging 1 over epsilon minus 1. So, eto yung kukunan natin ng limit. Okay, so take note, ang first na gagawin, get first the integral of or integrate first the given integrand, and then after that, i-evaluate nyo siya kung ano yung given na interval. What I mean is yung na change na ba or na transform na sa nalagyan na ba ng epsilon or nag-add na tayo or nag-subtract na tayo ng epsilon, and then after that, get the limit. So, ang limit nito, the limit of 1 over epsilon minus 1 as epsilon approaches 0 to the right or 0 to positive infinity. Always it approaches 0 to positive infinity. So, 1 over epsilon, so 1 over 0, diba? 1 over 0, the more na... Okay, so 1 over 0 is undefined. That is infinite, di ba? And then infinity minus 1, mas malaki pa rin yung value ni infinity. So the limit of this is equal to positive infinity. So ibig sabihin, ang result nito sa first is si positive infinity. Okay, so next, ang kukunin natin is yung sa second term. Okay, so doon tayo sa second term niya. The integral of 1 over x squared dx is equal to negative 1 over x. So, di ba, ito yung nakuha natin na integral niya. So, it is So, for now, it is evaluated from 0 plus epsilon to 1. Kanina kasi na from negative 1 to 0 minus epsilon. Okay, so if we substitute 1 here and 0 plus epsilon, we obtain negative 1 plus 1 over epsilon. Kasi negative 1 over 1 is negative 1. Negative 1 over 0 plus epsilon is negative 1 over epsilon times the negative here. So, magiging positive 1 over epsilon. So, ibig sabihin nun, ito yung kukunan natin ng limit. So, we have the limit of the integral of 0 plus epsilon to 1 over x squared dx as epsilon approaches 0 to the right is equal to the limit of this one, negative 1 plus 1 over epsilon as epsilon approaches 0 to the right. So, we have the limit of negative 1 is negative 1. Limit of 1 over 0 is 1 over 0 is undefined, so that is infinite. So, negative 1 plus infinity is infinity. So, ibig sabihin nun, eto yung, di ba ang result kanina sa first term is positive infinity, and then yung result din sa pangalawang term is positive infinity. So, infinity plus infinity is equal to infinity. So, we can say that the given integrand does not exist. Okay, for the last example, the given integrand is dx over x raised to the power of 1/3. So, evaluate if it exists, if the limit of this does exist. Okay, so the integrand f of x is equal to, this one is 1. This is not dx. Okay, so 1 over x to the power of 1/3 is discontinuous at x is equal to 0. Diba? If we replace 0 here, the function will become undefined. So, which means, discontinuous si function na to sa point na 0. So, which is in between the interval negative 2 and 3. So, di ba ang given natin na interval is negative 2 and 3. So, si 0 is nasa gitna nila. So, ang mangyayari dito, ang pag-split natin dito is katulad doon sa previous example natin. So, we have the integral of dx over x to the power of 1/3 from... Okay, so, since si 0 is between sa interval na to, so we can split this one as negative, integral of dx over x to the power of 1/3 from negative 2, kasi diba from negative 2, and then si 0 is dito natin siya ilalagay sa taas kasi 0 is between negative 2 and 3. Okay, and then plus the integral of dx over x to the power of 1/3 from 0 to 3 naman. So, ibig sabihin lang nito, ang interval natin is from negative 2 to 3, and then discontinuous siya at the point 0. So, since discontinuous siya dito, we are going to subtract epsilon here, and dito naman sa baba is we are going to add epsilon here. So, the same process pa rin kanina. Eto, before natin siya i-evaluate, and then before natin kukunin yung limit niya, get first the integral of this. So, the integral of dx over x to the power of 1/3 is 2 over 3, or this is equal to 3 halves. Kasi diba, fraction yan. Pag ilagay natin siya doon, magiging 3 halves, the reciprocal, times x to the power of 1/3 plus 3. So, eto yung gagamitin natin na result ng integrand. Okay, so, ito yung i-evaluate natin. So, we have the integral of dx over x to the power of 1/3. Ito yung uunahin natin, yung sa first term. So, it is equal to 3 halves x to the power of 2 over 3, evaluated from negative 2 to 0 minus epsilon. Okay, so, when we are going to evaluate this, we get 3 halves times the cube root of epsilon squared minus 3 halves cube root of 4. So, ito yung kukunan natin ng limit. Okay, so to get the limit, so di ba ito yung result kanina? So, as epsilon approaches 0, so this one is magiging 0 na to. And then, ito is constant lang siya. So, 3 halves times the cube root of 4. So, ito 0 na. So, we're left with negative 3 halves times the square root of the cube root of 4. So, ito yung limit ng first term. Ito yung limit niya. Okay. So, next, ito na naman yung kukunan natin ng limit. Okay. So, the integral of dx over x to the power of 1/3, for now, it is evaluated from 0 plus epsilon to 3. So, the same integrand pa rin yung gagamitin natin. So, when we are going to evaluate this one, we obtain 3 halves times the cube root of 9 minus 3 halves times the cube root of epsilon squared. Okay, so eto yung kukunan natin ng limit. So here, substitute natin dito. So limit of 3 halves times the cube root of 9 minus 3 halves the cube root of epsilon squared as epsilon approaches 0 to the right. So replace epsilon by 0. So eto, magiging 0 na siya. So we have 3 halves square root, the cube root of 9. Okay? So since eto yung nakuha natin na sagot, ibig sabihin nun, di ba ito yung original natin na given? So, ito yung result sa first term, sa pag-split natin. And then, ito naman is galing siya dito. So, pag i-compute natin to, it is, may makukuha tayo na value. So, which means, the limit does exist and then it is convergent. Kasi, define yung nakuha natin na limit. So, this is for the improper integrals with discontinuous integrand. So, ang tatandaan nyo lang, ang first process sa improper integrals with discontinuous integrand is tingnan ninyo kung saan magiging 0 yung, kung anong point or anong value ng x yung makaka-0 sa denominator. And then, kung magiging 0 yung denominator doon sa point na yon or sa value ng x na yun, ibig sabihin doon siya discontinuous. And then, sa point na yon, it's either mag-a-add kayo doon ng epsilon or magsasubtract kayo ng epsilon. Depende, kung nasa baba siya, dito siya sa baba, discontinuous, ibig sabihin mag-a-add kayo ng epsilon. Kung sa taas naman, magma-minus kayo ng epsilon. And then, after that, i-evaluate nyo siya. And then, yung integrand na nakuha ninyo, result sa pag-integrate ninyo, yun yung i-evaluate ninyo. And then, after that, get the limit. So, that is for the improper integrals.